Hey guys, it's Ferdinand Nandi here. How's life going on these days? How's our DIY hobby? In this video, let's talk about the Arduino HMI, and we're specific to the power supply, the onboard power supply in our casing like this, and that's our main topic today. Let me open my PowerPoint and this is the Arduino project power supply, the standalone, the modular, and also the SMPS integrated. There is the switch mode power supply integrated by yours truly once again. This is the SMI amplifier front panel of the DR100W concept project. And my next slide is to welcome you back to the Arduino HMI. The focus is on power supply. And these are the topic that we will take today. The Arduino A3CS onboard regulator and step-down PSU, the standalone power supply, which is a dedicated system, the modular link from Highlink, the alternative modules, integrated SMPS with enable port, and enjoy the video. In the first videos, I am using the personal computer, my notebook, to power on the Arduino HMI plus 5 volts from the USB port. And also sometimes I use the power bank, which is also a plus 5 volts. And that is enough to power on the whole Arduino HMI with hardware, relay, and the switch with LED. And in my last video presentation, I'm using the external plus 5 volt adapter and a USB to power it on to demonstrate how to use the Arduino with an analog power supply. But our main objective is not to connect the Arduino into the computer. We wanted to have a standalone like what I have here right now in this demonstration. And inside the A3CS shield, we have two kinds of regulator. The first one is a standard plus 12 to 18 volts DC input based on the LM7806. This one in here, this is the LM7806 regulator. And the other one is based on the LM2596. This is a DC-DC converter module with a high input with a maximum of plus 40 volts. This one in here. So what it meant by that is that if I'm using the Arduino HMI with the A3CS shield and my input range of voltage is 12 to 18, I'm going to use the LM7806. But if my input is greater than 18 volts and maximum is 40 BDC, I'm going to use the LM2596 module. Let's see the schematic diagram, and this is the schematic diagram of the A3CS shield. Let's see the input. So we have CON5 here, which is the input, and we have a blocker diode in here in case you reverse the polarity of the plus and the minus, the GND. We have D1 and D2 as a blocker, and we have two kinds of regulator in here. The first one is the DC-DC down converter, which is the module based on the LM2956, and the other regulator in here is the passive regulator LM7806. So this jumper setting in here, if we set that to P1, we are using the module, and when we are setting that into P2, we are using the IC1 direct, which is the LM7806. So as simple as that. Of course, for direct use of the LM7806, you need to set the J6 and J5. So pretty simple for anyone who is knows how to read the schematic diagram. So I'm not going to go further on that, but basically this is how to cater between the range of input for the AC3 shield. And just to remind you guys that For the LM7806, the range of voltage input is from plus 12 volts to 18 volts BDC. And for the LM2596, the range is a maximum of plus 40 volt DC. This is the maximum input. Remember that, guys. The next slides, if I'm going to put that into a block diagram with the previous information that I have, we have an 220 volt. Oh, what's that? We have a 220 volt AC plug-in, and then we were going to use a 16 volts SMPS. This is an external SMPS, and 16 volt is the range of input for LM7806. So it's pretty sure that we can use it in the Arduino HMI with the AC3S shield, and that will give you an output of plus 6 volt BDC. However, if the input is plus 24 volts, say that we found an external power supply of plus 24 volts, and if you're going to input that into the Arduino HMI, then it's better to use the LM2596 module, which is depicted in here, and you need to adjust that in order for you to obtain a plus 6 volts output, which power on your system, the Arduino Uno, including the external relay plus the SW1 switch. And this is my video actually. This is my Arduino PSU circuit and design philosophy, if you call that design philosophy. And if I'm going to click this one, it will take you to a YouTube videos. That's the one. And it will discuss to you about it. Arduino project before from my 3 minutes of video introduction and the formal video introduction. We're not going to watch this video right now. If you like to watch this video, I put down the link on the description below, and you can watch it. But for now, we're gonna focus on our PowerPoint. So let's go to the next page. And we have here a module with the small transformer on board the PCB, and we have also relay in here. And this is how it the block diagram. So from a 220 volt standpoint, going to a small transformer in here, that's the small transformer in there. I have also a rectifier, and we get also capacitor to smooth out the DC voltages. And then those small capacitors in there, those are the capacitor, and hidden is the rectifier. The regulator is in here with a small heat sink, and then that will be going to go for a plus 12 volts, and then the relay is in here, and we've got the bunch of connector in here for the interface, like this one in here, this one, and this one, which is one interface to the A3CS shield. This is how it looks like. As I go on with the power supply, I able to find some modular PSU, which is self-contained from the company Highlink. I mean the brand Highlink, and this is how it looks like. So you can imagine this is just a small switch mode power supply. I'm not really sure exactly what is inside, but I'm guessing that these are switch mode power supply, and the current that capable of is from 250 milliampere, and the current one that I have right now is maximum 2 amperes, from 6 volts or 5 volts to 12 volts, and the block diagram is like this. We have a 220 volts in here, input into the module, and it will give you an output of either plus 12 volt DC or plus 5 volt, that is a DC output. We have also the modular PSU, which is a DC to DC down converter, and this is the picture. This is good if we have a higher voltage than the 40 volts for the LM2596. So the input range we're gonna be 36 to 72 volt DC with an output, a fixed output of 15 VDC, and the current capability is 1 ampere. And if I'm going to put that into the block diagram, again, we have an input of 220 volt AC, and we get a transformer in here, and a rectifier and a capacitor to smooth out the DC. And assuming that we have here about 60 volts, the maximum will gonna be 72 volt DC. That is plus 72 volt DC, and we want to use this module in here to have an output of plus 15 volt DC, which is good enough for the LM7806 inside the A3CS. That is the A3CS shield. All right, those are the solutions that I researched so far, and I have used them in an actual application. The one that I have here right now is my favorite because it gives me the leverage to use it and reuse it in a different application of my own personal DIY power amplifier, like what I'm using it right now. I'd like to have a simple presentation in here wherein I use my personal design for powering up the Arduino HMI with an A3CS boards. So that's the one that I designed. This is just for demonstration in here. Again, my setup, I would like to emphasize again about the safety, what is I'm using the safety valves before I'm going to plug in this unit under test. To the main power supply over there, and that's the standard one supposedly whenever we are testing a new circuits or a new boards. Let me put that one into the ohmic range, and I'm going to put that into the screaming. There you go. I'd like to mention a little bit of the configuration in here. So this is the design power supply. I don't have a name for it right now. And this is the transformer convert 220 to plus 16 volts. And this is the regulator for plus 12 volts. This is the relay. This is a plus 12 volts relay. And you can see this one in here. This is the control for the relay, and this one in here, this is the plus 12 volts which is power up the Arduino HMI. So that's pretty easy, and you can see in here this is hanging. This is the control for the relay actually, so I'm not using this relay right now in here because there is already relay in there. This is just for the demonstration on how to power up the Arduino HMI with the A3CS shield. It is a self-contained that I'd like to have it inside my casing. So setup is ready. So I'm going to power on the 220 volts right now on the switch, and you can see that this power supply in here is power on with the LED in here, and the Arduino also receive the power with the blue LED in there. And if I'm going to press, this is my hand, and I'm going to power it on the amplifier right now. There you go, and it's screaming. So that's really hurting my ear. So this ohm meter in here is reading is 0 volts, and it is connected to the normally closed of the relay. And again, it is connected to the normally closed, and when it is power on, the resistance will gonna be basically 0 ohms. If I power off, you can hear the kick of the relay, right? If you power on again, you can see the noise or the kicker of the relay. That's from the relay in there, not this one in here. Well, this is a simple demonstration how to power on a self-contained power supply inside the casing to power on our project, the Arduino HMI with the A3CS shield.